Welcome back, this is T-Cypher and I'm going to continue my series of videos looking at the construction of sim-pit panels for the AV8B Harrier. In the last video we had a look at creating the engravings and such like on top of the panel. This one is going to be a bit more on the fly. We're going to have a look at how I'm looking at backlighting it, how you actually assemble the models together in DCS, in Fusion 360, and I'm going to be looking at a few other steps and things I've done and just show you my progress up to date. Okay, switching to Fusion 360. Okay, so you'll notice immediately I've moved on with the model quite a bit. I've done an assembly with the switches in place. I've also constructed this part here, which is it's a protective cover, I think, over the dump so that you don't accidentally flick them. I've also modeled in the DCS housings and just assembled it as a complete model. But what I'm going to look at first of all is I'm going to look at the aluminium backplate. So looking at the aluminium backplate, and let me just change the display setting here for the camera back to orthostatic. How do you pronounce that? And what you can see, I've added a lot of cutouts and such like. Okay, so these holes here, for instance, these are actually located underneath where the rings here are located. And if I go into the assembly here and if I hide out one of these toggle switches, you can see they're not quite in this back region here, but the idea is that I'm going to be backlighting this panel. So what I've done is I've allowed space for the light to come through from behind the panel and irradiate through the acrylic plate and give us the color that I hope to achieve. The position of these it was actually quite easy in some ways, because all I did was I went to this and here, oh that's not it, the upper panel here, and then I selected the sketch in question, which is this one here, and what I did was I exported it as a DXF. And what it does when you do that, unfortunately it doesn't export text, but what it does do is export the text box. So it gave me all these boxes already in place underneath where the text would have been. So I just then, all I did was, using techniques we've seen before, I pasted it into this assembly here, which would be, I believe, this model here, and then I just corrected it. And if I open up the actual sketch itself, you can see I just fixed a lot of it. I just trimmed it all, just giving all the general shape to enable this to be done correctly. Other things I've done in the meantime as well, just to be aware, I've updated my master dimensions to correct some errors, and I think I might have just spotted an error just now looking at this. Yes, there's a little one here, so we can just watch me do a correction here. So I'm just going to join these two together with a nice little arc. I'm going to use a center point arc because I like center point arcs, they look reasonably good. Oh, come on. Okay, this isn't stepping to the center. There we go. So center point on the center mark. First one there, second one there. Get these tangential to this. Okay, and now what I should be able to do, finish that sketch. If I just edit this feature here, I should be able to enable that block as well. And I'm doing this because there's no value in that material just there, and when I go to machining it, it's better to not have that sort of harsh little bit of material which isn't doing anything. Yeah, so this is how I've gone around sorting out the cutouts. Also, what I'm going to be using, these 4 points here that I'm using for the manufacturing and location of the acrylic plate, is also going to have standoffs in the back of the end of aluminium. So I'm going to have a longer screw, and those standoffs are what's going to be mount the circuitry I need for these panels and the backlights. That's my plan at the moment, and that's no doubt going to change. Yeah, so going back to the main panel, let's close that off. Okay, you can see that I've done that, and then we've got this little part here with this protector, as I called it actually. So if I just open this up, just so you can have a clue on how I constructed this. And I did actually find another reference, and I think it was from a different game, and it gave me a lot better view of what was going on down in that section. And you can see what I've done is I've just created an initial block, then cut out the center, made it cut out the top arcs, cut out the profile there, smooth off some radiuses, and then I've just extruded out this center mark there. And I'll just see if I can bring up this other reference I found to show you. I think it was this one here, maybe. Yeah, it's this one here. You can see down here it's it's obviously from another simulator. I don't know what, but you can see that this feature is actually there, unlike on the DCS one, and you can see what it is. So that's that there going on there. Yep, so I created that, and what I want to just show you now is just as a skill, another skill to learn, is how we go about connecting these points together. So if I just take this part here, what's that part? Okay, so if I just delete this here just for a second, you can see this is how when I import it. And to import a part, all you do is literally drag it in, drop it, and it'll bring it in, and I normally just bring it up to give me some clearance to play with. So how do we connect things? So we use this joint function here. There's probably other ways. I'm not that fond of this joint function. I'm used to having better functionality from SolidWorks, and it's probably there, but I just haven't discovered how to use it yet. So what you do, you select the first face. So I'm going to use this bottom of this hole here. This is the bit you want to move. So you select that, and then you select where it wants to mate to. So it's going to be the top of this hole here. And then that will just snap in. You can adjust the alignments here and flip things left, right, and center. There might be other forms of alignment. So actually, between two faces might be a better choice. You'd have to play with that. Using hole alignment is working for me so far, so it's not a problem. So that's how I go around assembling that profile. And let's just delete that one out because I didn't want it. Yeah, so there's that one. And I've actually moved on to a step even further. So let's don't save that one because I don't care. And what you can see here now is I've actually gone about and I've completed the other panels on the left console, lower console, and you'll notice this large gap here. That I'm using a Thrustmaster Warthog, and that's just to represent the space envelope for that. I like the Warthog. I could go around creating a custom made for the Harrier, but this does the job. It does the job for me at the moment. I might make some minor corrections to put in a physical nozzle stop into it, but I use it for other modules, so that's why I'll probably keep with that for the time being. But you can see I've gone through and I've made the external lights panel. I've made the I don't know what this panel is called, but it's got the oxygen and other things like that on there. The SARS panel, which is, in all honesty, it's just the fuel panel repurposed with new text put in place and the protector removed. And then I've got the this top little panel here, which has the taxi lighting, and I don't know what this particular switch here does. And then there's trim. I've called it the trim panel. So that's what I've been up to in the meantime. Going forward, I am in a bit of a I've been fortunate that I've been able to get a hold of a friend who has a friend who works at one of the few locations in the UK where there is a the AV8B equivalent Harrier in place. It would be a GR7 or GR9, and they've agreed to get me some high quality photos inside the cockpit. So hopefully by the end of this week I will have a full set of photos of the inside of the Harrier, maybe even some dimensions of some of these panel heights, and I might well have to go through and redo these panels, but hopefully with the better quality photos than that I've been able to find out there on the interweb, I should be able to make an improved job of these still, and it might answer some of the little questions about this might only be in the tab or it might be on some of the GR9s. I don't know, but it will be able to answer some of those questions, and it might hopefully give me a better ability to scale the drawings. Talking of scale, there was one other trick I learned recently, or discovered by accident. So I've just created a new item here, and what I'm going to do, I'm going to go insert canvas, and this is a really useful trick. So straight off my computer, let's find my reference documents. So pit, let's go find this one here will do actually, and then I'm just selecting that and plonking it down. So what it's done, it's imported the actual image I just placed. Why is this useful? I'll show you. So if I create a sketch on that profile, I can then use this as a way of reasonably accurately measuring things. So if I go from, say, up in this corner here, and I'll pick a point. Let's just have a look at the bottom side as well. Yeah, so if I pick a point here, so it's literally the top of that there, I can draw a line across the top of where that would be on there. I didn't mean to make that little one, but hey ho. And then I can do another one up here to about where I think the given perspective of height, it would end up just about there. And if I look across, maybe it's a little bit too far, so if I move it back to there. And what the bonuses of this is that I can actually put in a measurement there, and now I know what this distance here is in reality. It's this dimension that we got from the mil spec. See if I can bring up the mil spec. No, mil spec isn't wanting to come up, so I'll have to cheat it up. We know that this panel is 145.65, so simply by using Excel we can put in a simple formula where we go 145.65 divided by 7.462, then the resultant of that times by 4.212. So let's do this quickly. I'm going to just bring an Excel spreadsheet, lots of words at once. So 7.462 145.65 equals that equals that divided by that. And I can put in this one here. If I put in 4.212, I go equals that times that. That'll give me 82.21 as the height of this panel, and if I look back to this document here, 82.21 for height. Well, that's pretty much spot on for the 9 to Zeus. So there we go, nice and easy way of trying to scale the parts up. I use the same trick. Don't save that. I use the same trick to scale this, and that works out to be about an inch tall, I think, and that's how I went about creating this panel here. It's not perfect, but I think it's a strong contender, or it's a decent and reliable way of measuring things instead of trying to get your ruler against the screen and measuring it yourself. So I hope you found this slightly more chaotic video useful. Like I've said before, if you've got any questions, please feel free to leave them in below. And just for your information, we can see here's a nice little gap as designed in to allow for paint and for movement. And we can see how all these panels are lining up nicely. Moving forward, my hope is to my next one is, like I said, I'm going to get these new pictures up and I'm going to go back and rehash all these and make sure they're right. I'm then going to start working up this direction here and put in. I want to get the landing gear panel put in. I might also knock out the right panel, because once you've got the hang of it, it's quite easy going actually. Once you've got one panel, once you've got your dimensions and once you've got your technique going, I found it's quite easy to put in the other panels. I do also actually need to go through and actually put the backlighting holes in for these ones here, but that's relatively simple. But yeah, thanks for watching. Please feel free to subscribe if you want to, and I hope to see you in the next video.